Hello all. In this video, we learn about switch interfacing in MSP430. So this is a continuation of Introduction to Embedded System. Digital switch interfacing. If we want to interface a switch with MSP430, then it can be done either in pull-up configuration or in pull-down configuration. So here is a circuit diagram. The two possible ways are, one is like the resistor in the bottom and the switch in the top. Pull down configuration is switch in the downwards and the resistor in the upward configuration. Digital input resistors. MSP430 resistors required for switch inputs are the main pins are P cross DIR, P cross input, P cross output, and P cross REN. So the reading inputs. Suppose there is a switch connected to port 1.3 in a pull-up state and we need to read the value of the pin. Here is the snippet of code example for testing the individual bits in a register. If P1 in and bit 3 is equal to 0 or else, so that is the coding for if else line. Line coding. So next one is a switch bouncing. The common problem associated with the mechanical switches and relays made up of spherical metals which are forced to contact each other by an actuator. While they collide each other, there is a possibility of rebounding for some time before they make a stable contact. So hardware bouncing means VCC will be connected with the resistor. Switch will be connected in parallel with the capacitor. So that is called as hardware debouncing. Software debouncing usually provides a delay of around 20 milliseconds after the first change is detected. The next topic is clock system and reset. So this is a basic clock module. So here we have the dividers, the input pins, output pins, the NOT gates, the pulse filler, the DC generator, which generates the DC power supply, modulator, which modulates the power supply, amplifiers we have, oscillators we have to produce the clock signal, pulse filters are there to reduce the noise, internal oscillators are there to generate the clock signals. So this is nothing but the basic clock module. Simplified block diagram of MSP430 G2553 clock system. So here we have voltage low, DCO, and the auxiliary clock we have, master clock we have, subsystem master clock we have. So all are connected in series with each other. The three types of clock sources are DCO, LFXT1, VLO. DCO is nothing but a digitally controlled oscillator. One of the highlights of MSP430 is nothing but it is basically a highly controllable RC oscillator that starts in less than 1 microsecond. Therefore, it starts rapidly at full speed from LPM. The DCO frequency can be adjusted by software. DCO frequency ranges from 60 kHz to 16 MHz. The default frequency for the clock sources are 1.1 MHz. DCO clock is there here. It will be having a DC generator, DCO filter modulator, which is connected with a divider, which is connected with a basic clock source. So next type of clock source is LFXT1, low or high frequency crystal oscillator, used with low frequency watch crystal, also used with a high frequency crystal. Low frequency watch crystal is nothing but 32 kHz frequency. 400 kilo high frequency crystal is nothing but 400 kHz to 16 MHz frequency. So this particular circuit is nothing but LFXT1. The bottom one is nothing but DC. The third type of clock source is nothing but VLO, internal low power and low frequency oscillator. It will be having a frequency of 12 kilohertz. So VLO clock is nothing but the one which is there in the top internal oscillator, VLO clock. So this is VLO clock. This is LFXT1 oscillator, and this is DCO. So we have several types of clock signals generated by these basic clock sources. I hope you would have learned from this video. See you in the next video. Until then, it's bye from Radhika.